All right, today we're going to tackle one of JavaScript's most powerful features, classes. We're going to take a simple chunk of data and, step by step, turn it into a digital creature that can actually act on its own. So, let's dive right in.
So, check this out. This is where we're headed. These 4 lines might not look like much, but they represent the final, living output of our code. We've got a creature named Sparkling, it's announcing itself, using a special move, it's doing things. But of course, it didn't start out this way at all.
And that is the big question, right? How do we take raw information, just a collection of names and numbers, and breathe life into it? How does it learn to do things? To figure that out, we've got to go back to the very beginning.
You know, just like anything you build in the real world, you have to start with your raw materials. And for our digital creature, that raw material is just some simple, plain old data.
I mean, just look at this. It's just a table of facts. We've got a list of creatures, their names, their power levels, and notice there that Sparkling has that special charge property. But right now, this is just text. It's like a bunch of trading cards sitting on a table. They're interesting to look at, but they can't actually do anything.
And that's the key thing here. This data is static. It's frozen. It can't attack, it can't use its charge, it can't even say its own name. It just sits there. To bring it to life, we need something more. We need a blueprint.
Okay, so how do we actually do that? How do we give this pile of data some life? Well, the answer in JavaScript is something called a class. And this is going to be the blueprint for our creature.
Seriously, think of it exactly like a blueprint for a house. The blueprint itself isn't a house, right? It's just the instructions. It says a house needs walls, a roof, some doors. That's the data. But it also defines how those things work, like how a door opens or how a light switch turns on, and those are the functions. A class does the exact same thing, but for our code.
Now, inside every class, you've got this special function called a constructor. You can think of this as the very first station on the assembly line. Its job is to take in all that raw data we saw, the name, the power, the HP, and assign it to the new creature that's being built. It's the essential first step of construction.
Okay, so the constructor gets the creature built. But now what? What can it actually do? That's where methods come in. Methods are really just functions that are attached to the class. So in our creature blueprint, we've decided that every single creature made from it will automatically know how to do 2 things, sayName it and attack. Those abilities are baked right into the design.
So our basic blueprint is awesome. It works. But, what happens when you have a special case, a creature that's a little different from the rest? Do you have to draw up a whole new blueprint from scratch?
Remember back at the beginning? Sparkling was a little different. It had that unique charge property that our basic creature blueprint doesn't know anything about. So does that mean we have to design a completely separate blueprint just for this one creature? Well, the answer, thankfully, is a huge no.
We can use a super powerful concept called invariance. It's kind of like taking that original blueprint, throwing it on a photocopier, and then just drawing your own custom stuff right on top of the copy. You get to keep everything from the original design, and then you add your own unique features. It's a huge time saver.
So let's walk through this step by step. It's actually pretty simple. First, we use the keyword extends to tell our new Sparkling blueprint, hey, copy everything from the main creature blueprint. Then, inside its constructor, we call super. That just means run the original setup from the parent blueprint first. And only after that's done do we add our own new stuff, like the this charge property and a brand new special move method.
All right, we've got our blueprints. We've got the standard model and the custom one. Now comes the really fun part, actually manufacturing our creature. It's time to bring it to life inside the code.
First things first, we got to find the right pile of raw materials. We need to go back to that original list of data and pull out the specific info just for Sparkling. All we're doing here is grabbing the correct set of instructions for the assembly line.
And this brings us to a super important word, instance. When we finally use our blueprint to build one specific creature, we've created an instance. Remember, the class is the blueprint, but the instance is the actual house. It's the finished product, the thing we can finally interact with.
In this line of code, this is where the magic happens. That little keyword new is like a magic wand. It tells the computer, hey, take the Sparkling blueprint, use this specific data we just found, and build me one. And boom, just like that, our Sparkling object is born. It's alive.
And look at that. We're right back where we started. But this time it's not magic. We know exactly how this happened. Each one of these lines is just the result of us calling a method on our brand new Sparkling instance. We've done it.
We've turned a static piece of data into living, interactive code.
Okay, so that's the how. We did it. But the bigger question is, why? Why do programmers work this way? What's the big deal about using classes and creating instances?
Well, it gives us some huge advantages. First, organization. All your related stuff, the data and what it can do, is tucked away in one neat package. Then there's reusability. You write one creature blueprint, and you can stamp out 1,000 different creatures from it. It's also scalable. Need to add a new fire type creature? Easy, just extend the base class. And maybe most importantly, maintainability. If you need to change how all creatures attack, you don't have to fix it in 100 different places. You fix it once in the main creature blueprint, and every single creature automatically gets that update. It's just so clean and efficient.
So think about what we just did. We took dead, static data, we gave it a blueprint using a class, we even made a specialized custom version of that blueprint, and then we brought a living, breathing instance to life. We've basically unlocked the core pattern of object-oriented programming. The only question left is, now that you have the blueprint for turning data into action, what will you create?